Here are the main devices for the Hall effect experiment. The toolbox on the left includes the electric circuits, the semiconductor sample, inserted in the green piece of circuit board, and a magnetic field induced by a coil. The button here is used to adjust the position of the sample. Here in the circuit part, from right to left, the first button is used to switch the direction of the magnetic field by changing the sign of IM. When the up indicator is on, the sign of B is positive. Otherwise, it is negative. The second button is used to switch the direction of IS in a similar way. The device on the right is used to adjust the value of current, IM, IS, and read out the voltage, VH. Now, let's begin part A. In this part, we need to keep the value of IS at 3 mA and change the value of IM from 100 mA to 1000 mA. We need to measure the VH values according to different signs of IS and B. For example, to measure VH1, we need to switch both of them to positive direction. To measure VH2, we need to switch B to negative direction. In part B, we need to keep the value of IM at 300 mA and change the value of IS from 0.5 mA to 4 mA. We also need to record the VH values in the same way as part A. In this part, we will need to measure the intensity of the magnetic field by a Tesla meter. First, turn on the power, then keep the black spot forward. Put it inside the magnetic irons and finally, we can read out the result from the screen. We need to repeat this operation 3 times and take the mean value. In part C, we need to keep the value of IS and IM unchanged and measure the distribution of the magnetic field. Here, we need to adjust the position of the sample from -20 mm to 20 mm and record the VH values in the same way as part A and part B.